Over the last few days, I have been doing a lot of videos on TinyLlama. I have done fine tuning of TinyLlama, how to install it locally on Linux and Windows, and how you can do retrieval augmented generation with Llama, or TinyLlama, I should say in this case. So far, I have found out that provided just the 1.1 billion size of this model, the performance is simply fantastic. The quality of the responses, the inference time, and everything around it is quite good if you compare it to relatively larger models. Still, my favorite model is Mistral, but having said that, I think Tiny Llama is just one of the five top models which I am following very keenly at the moment. I believe that in the future and not very far future, this Tiny Llama would be one of the top models, if not already, in so many domains. One of the things which I wanted to share in this video is that they have recently released the full paper as how they created this Tiny Llama, how they pre-trained it and all that stuff. Now, if you're not aware of what Tiny Llama is, let me give you a quick overview. Tiny Llama is a compact 1.1 billion language model pre-trained on around 1 trillion tokens for approximately 3 epochs. The researchers, which include Pion Zhang and their colleague, they have built on the architecture and tokenizer of Llama 2. Tiny Llama leverages various advances contributed by the open source community, such as flash attention, and hence they have achieved better computational efficiency. The size is small, but don't let that size deceive you. Tiny Llama still demonstrates remarkable performance in a series of downstream tasks. It has already shown that it can significantly outperform existing open source models like in the 7 billion range, of course. And another great thing is that their model checkpoints and code is publicly available on GitHub, which I just showed you, and I'll drop the link in video's description too. If you look at their pre-training, which I just mentioned, they have used a lot of technologies from other models, especially from Llama, as I mentioned earlier. For example, they have adopted a mixture of natural language data and code to pre-train Tiny Llama. So they have obtained it from Slim Pajama, Star Coder data, and tokenizer they have taken from Llama. And then they have described what Slim Pajama and Star Coder data is. And then if you scroll further down, they have described their architecture of this Tiny Llama. For instance, for positional embedding, they are using rope or rotary positional embedding. Rope is primarily a positional encoding or embedding which encodes absolute positional information with rotation metrics and naturally incorporates explicit relative position dependency in self-attention formulation. So that has really made a huge difference in the performance of this Tiny Llama. And then they have used RMS norm in pre-normalization, and they have also normalized the input, which has again made a huge difference and increased the training efficiency. And then there are a lot of other things, as I mentioned, group query attention earlier. For that, they have used 32 heads for query attentions and 4 groups for key value heads. And there is a lot of other detail which you can check out. Most prominent one is this flash attention, where they have done this critical improvement, and that is why their computational throughput has increased a lot. And they have then a section on training as how they did the training, and then they have shared the results, and you can see the comparison of Tiny Llama 1.1 billion with lot of other similar model like Pythia and OPT, and you can see that it has performed fantastically well on almost all the benchmarks. So that's it, guys. I hope that you enjoyed it. Really hats off to these researchers who have done a fabulous work in creating this Tiny Llama. And I'm more than sure that more and more tiny LLMs will be launched so that we can use them on our own systems easily without wistfully wishing for the GPUs and high-end beefy systems. If you like the content, please consider subscribing to the channel, and if you have any feedback, please share it in the comments. Thank you very much.